now we're going to do a scenario where we're going to try and prove some identities are true. And we're going to get things that look like this big giant equation.
And basically all you want to do is make the left side equal to the right side.
Exactly. And you're only allowed to work with one side to make it look like the other side. And you can't treat it like an equation. So some of the hints that are good for it, you start with a more complex side. Expressed in terms of one of the ratios. So put them in terms of sines and cosines typically. Do the math it asks is a good thing. So you either add the fractions or you multiply or you try to factor and simplify. Sometimes you want to convert to sine and cosines. You look for some of your identities like the tangent is sine over cosine or the cos squared plus sine squared equals 1 to substitute. And you work on one side or the other side. Do not solve the equation because that's not what you're trying to do. You have to work on one side and then go to the other side. So let's try one. So we have tan x plus 1 over tan x equals 1 over sine x. Well, if I look at those two, this looks like the more complicated side. So let us start with the left side here. So I have tangent x plus 1 over tangent x. And then let's put, it says to add. So let's add. So
common denominator?
Common denominator was going to be tangent x. And so to do that, I've multiplied this by tan x.
So I get tan
over tan x. So it's tangent squared x plus 1. So now I know on the right hand side is where I'm trying to achieve, trying to get to this. I have sines and cosines. So let's take this
rewrite it
and put sines and cosines. So tangent squared is just going to be sine squared x over cosine squared x plus 1 all over
sine x over cosine x.
Right. Okay, and I come on down the page a little bit. So now I got ugly fractions to work with. I know when I'm multiplying with fractions, I have to flip, or when I divide fractions, I flip to multiply. So I have sine squared x over cos squared x plus 1. This fraction, I'm going to multiply it by
the reciprocal.
Right. So I flip it to cosine x over sine x. And now I have to multiply that. It's getting ugly. And this often happens with trigs. It gets really ugly, and then it tidies up nice at the end. So if I distribute that, I get cos squared. No, I don't. No. Oh, good thing you're here. Let's back up there. I get sine squared x times cosine x.
It's all over cosine squared x times sine x.
All right.
Plus cosine x over sine x.
Now, if you're following along, you should probably pause it one of these times and try and do the algebra yourself. Then you can check and see how you're doing as we're doing it. So if I come along here now, I can do some canceling, which I always like to do. This one cosine will cancel out this one. This one here will cancel out this sine.
Nice.
And so it's getting a little bit better, but still a bit of a mess. So I have sine x over cosine x plus cos x over sine x. And I need to, it says to add, so let's add. Common denominator, we're going to be multiplying this by sine x over sine x. And this one by cosine over cosine.
So on the left-hand side, we're left with sine squared x over sine x cosine x plus cosine squared x over sine x cosine x. Now we're able to add. So the numerator, we have sine squared x plus cosine squared x all over sine x cosine x. Well, that's easy now, because our numerator, we recognize that that is one of our trig identities.
Ah, right,
to
that
be
is
1 over sine x cosine x.
And that is equal to the right side, if I remember correctly.
Just double check. It's always a good idea to make sure to check back to see what you're trying to prove as you're working through your problem.
Go to the top. It is indeed 1 over sine x cosine x. And so I was able to prove that identity. There may have been a shorter way to do it, but usually you just keep on going, keep plugging. Hopefully you don't make any fraction mistakes, and you'll get it all the way through. Let's try one more. This is similar, but it's trying to show that this big thing equals 13.
All right,
Well,
here we go.
it says to square, and this one says to square, so let's do what it says to do. So
we have 4.
how would I square as opposed to just write it down?
Okay.
Okay.
So we have 4 sine squared beta.
Beta. Love the Greek letters. Plus
Plus
12 sine beta cos beta. I did that in my head. You double the product of the two.
You're smart.
Plus
9 cosine squared beta.
Plus, ooh, this is getting big. I'm going to go down here a little bit. Plus
9 squared beta. Do that one in your head. Minus 12 sine beta. Cosine beta. Plus 4 cosine beta. We all know what it is.
Cos squared beta. Okay. Well, what are we going to do now?
Simplify.
Well, to
Do you like terms?
simplify, I like terms. I have this one and that one. I have this one and that one that looks really messy.
And those guys are gone.
And these two will go plus 12, minus 12. They cancel away. So let's see what
How
that...
convenient. I'm only already recognizing 9 and 4 is 13.
All right. Sine squared beta plus 13 cos squared beta. We'll factor out the 13.
And we're left with our trig identity.
And so it's 13 times 1. Hooray! Yay. 13. That's trig identities. It gets messy with the fractions, but you have to work your way through it and just do what it says to do. Good luck.